watch this again later. All right, so we have some questions from geometry, kind of like a review for Algebra 1. So the first question here says, find the value of x for which those two lines are parallel. Well, they're parallel if the opposite, or I'm sorry, these are called alternate interior angles. If those two are equal, then they're parallel. So we make sure they are equal by setting those two expressions equal to each other. 22x minus 24 equals 94. Yeah. And then we solve for x. So what's the first step to solve for x?
You plus 24 to the 94.
So we have 118.
18, yeah. Yeah, that's right.
2x equals 118, and then what?
Then you gotta divide 118 divided by 2.
What do you get?
You got
half of 100 is 50, half of 18 is 9, so 59, right?
Yep.
So 59 will be your answer. Good?
Yeah, all good.
All right, next question for what value of x is m and n parallel? So again, now in this instance, notice these are alternate exterior angles. So these are the two lines in question. This is the transversal, and this angle are alternate exterior, and those also have to be equal to each other. So again, we set up an equation. Just wrote that wrong. 3x plus 12 equals 4x minus 27. So what's the first step I'm going to do here?
Probably, I think combine like terms is 3 plus 4.
Well, I can't combine them until they're on the same side.
So
I first have to move them.
Minus 12, right? To negative 27.
You could, but can I make a suggestion before you just start doing that? Think about what would it be better to move the x's to the right side or to the left side?
Probably the left side.
Well, so that's where it'd be better actually. See how this is a bigger number? It would be easier to move it to the right side because then you wouldn't have a negative to have to deal with. And negatives are where a lot of people make mistakes. So I would suggest, since you can do either one, I suggest just subtracting 3x from both sides.
Yeah.
And then you'll have 12. In fact, we can at the same time, we can go ahead and move the 27 over to the left side. So how do I move the 27 over to the left side?
You do plus 27 to the 12.
So you're adding 27 to both sides. And when I do that, I get those are gone, those are gone. I get x on the right side, and I get good 39 on the left. And you see how that was easier than having a negative? If you did it the other way, you'd have negative 39 equals negative x. And not that that's horribly difficult, but it's just one less step and one less thing to worry about. And really, you didn't have to deal with any negatives either. So this problem on page 4 says simplify the product. So a product means you're multiplying two things together. So I'm multiplying these expressions together, x plus 4 and x plus 9. And in order to multiply these two things together, I have to do what's called FOILing, if you remember. First, outside.
And then you do so you do x times x, but don't you have to don't you put like a little 2 above the x because you're doing an x times an x?
Yep. So x times x is
x
squared. Right? That's your first. What's your outside?
And then you x times 9, so 9x.
Plus 9x. What's your inside?
And you 4x plus 39. 36.
Yeah, I knew what you meant. 36. There's your FOIL. And then what can I do to simplify that? Is there anything I can do?
Combine the like terms 9x plus 4.
Which is?
15x.
Good.
So x2 plus, and that's the end of the answer, right?
Yep, that's it. Can't simplify it anymore. Now, let's take a moment here and take a look at what if they gave you this problem and they said factor it. You're going to actually do the exact reverse. You're going to try to come up with this right here from this. And that's what one of the major type of factoring that you will do, and it's probably what you're going to be doing pretty soon. It will be that exact problem. So I want to just point out how you would factor it. If they said factor, if they gave you this problem and they said factor, what I suggest people do is they take their parentheses, because they know it's going to look something like this when it's a trinomial like this, a quadratic trinomial. They know it's going to, if it factors, it's going to look like that, right? Okay. Most likely. Mm-hmm. And so when you see that, you just take this and you think to yourself, well, I want the first to come from here, and I want the last, meaning the first needs to come from there, and I want the last to come from there. And then I want the outside and the inside, these ones, to add up to 13x.
Yeah.
So you literally just deconstruct it and you think to yourself, well, my first, well, the only way I can break, what's the only way I can break up x squared?
By combine.
What are the factors, I should say? What are the factors of x squared?
2 x's, right?
That's right. So one of the x's is going to go here and one of the x's is going to go here. Mm-hmm. And then what are the factors of 36?
4 and 9.
Well, you can do 4 and 9, or you can do 6 and 6, right? So you might try 6 and 6 first. Mm-hmm. You can even do 2 and 18, right?
Yeah.
So there's lots of options, and you can even do negatives. These can be both negative if you wanted to. -4 and -9. There's lots of options, right? So, but what you can do is, you know that, well, let's just try one. This is called guessing. And now let's check it. Let's check if the outside plus the inside equals this middle term here. Does that 6x plus 6x equal 13x?
No, it equals 12.
It doesn't. It doesn't, so you know that's not the right answer. So try something else. Try 4 and 9.
That does equal 13.
Mm-hmm. And 4 and 9, as we know, equals 13. So you know, oh yeah, that's it. 4 plus 9. You understand? So this going from here to here is called factoring.
So when you're doing that, it has to be something that adds to the x and then multiplies to the regular number?
That is exactly correct. Okay. That's even the little riddle I like to say. What multiplies to 36 and adds to 13?
Okay.
And the answer is 4 and 9. Now, that only works when you have 1x squared in front. If this was something like 2x squared or 4x squared or 3x squared, that doesn't work. That little method doesn't work. And instead, you have to do a little bit more. It's a little trickier. You have to like put if this was a 3 here, you'd have to put the 3 in front of one of the x's here, either that or that.
Yeah.
And then it's a little bit tougher because now you got to do some more multiplying, right? But it's still the same concept. You're trying to make it look something like this. And so you're just guessing and checking using the factors of that constant term and the factors of the first term.
Okay.
Does that make sense? So I'm going to refer back to that when we do some of these other problems. So again, it says simplify using the distributive property. Again, this is the unfactoring. This is multiplying, and factoring is basically like dividing. So there's my problem, and I'm going to FOIL it out. I'm going to even color code this one. There's my first. There's my last. Here's my inside. I'm sorry. Did I do that right? I didn't do that right. This isn't your last. This is your outside. My fault. This is your outside. This is your inside. And this is your last. Mm-hmm. Got it? So x squared is your first.
So yeah, the x squared.
What's your outside?
5x.
Plus 5x.
And then
what's your inside?
3x.
Mm-hmm. Whoops. minus 3x. And what's your last?
Negative 15.
Good. So what is it all together?
You do 5 minus, so you got x squared plus 2x minus 15.
Perfect. And if I ask you to factor it, guess what you'd get? You get that back if you did it right.
Yeah.
What multiplies to negative 15 and adds to 2?
What was it again?
What multiplies to negative 15 and adds to 2?
3? 1? I don't know.
Think about it. What multiplies to negative 15
Yeah.
and adds to 2?
Negative 15.
Think about all the ways to break up 15. How can I break 15 up?
You do 15 divided by 3.
Which is what?
15. 5.
So how about negative 15? One of them has to be negative, right?
Yeah.
And one of them has to be positive.
Mm-hmm.
So those are your two options. So let me ask the question again. What multiplies to negative 15 and adds to positive 2?
5.
5 and what?
3. Or negative 3.
Positive. Good. 5 and negative 3. And that's exactly what I have here. 5 and negative 3. That makes sense? So that I'm using this problem to help you understand how factoring works, because we're going to get to that pretty soon.
Yeah.
Let's do some. Can you find some factoring problems that you've got?
I'm gonna go look for some right now on this homework. Here we go. I got one.
Go ahead and just tell me. I'll write it out.
Okay, it's x squared plus 16x plus 63.
Okay, so let's ask the riddle. You ready?
Yep.
What multiplies to 63 and adds to 16? So let's take 63 over on the side and let's just start breaking it up. What's 63 divisible by?
Is it 63? Hold on. Sure.
Do you know the divisibility rules?
No, I don't think so.
So this is a good thing to know. One of the divisibility rules is that if the digits of a number add up, if the sum of the digits of a number is divisible by either 3 or 9, then so is the number.
So you could do like 63
6 plus 3 is 9, so you know that 63 is divisible by both 9 and by 3.
Yeah.
What's that?
7 goes into 63.
7 and what?
7 and
9, right? Like I just talked about. It's divisible by 9 because the sum of the digits of 6 and 3, the sum of the digits of 63, 6 plus 3, is divisible by 9. You understand that?
yeah.
Let me go over the divisibility rules real quick, because a lot of times they don't teach this anymore. So how do you know if these are the divisibility rules or tricks? You can call them tricks or rules. Every number is divisible by 1, right?
Yes.
Okay, how about 2?
A lot of them are.
Every what kind of number?
Every positive number?
No, not every positive number is divisible by 2. Every even number.
Yeah.
So what do they end in? What do even numbers end in?
What do you mean?
0, 2, 4, 6, or 8. Okay. How about divisible by 3? I just told you what that rule was. Divisibility for 3?
Yeah.
Or I should say divisibility tests, maybe, not rules. I can't remember what they call these, tests or rules or something. But a number is divisible by 3 if the sum of digits is divisible by 3.
Mm-hmm. So if it's divisible by 3.
So is the number.
All right.
In fact, if and only if, meaning it goes both ways. If it's not the case, then it's not divisible by 3.
But since
Okay?
there's a 9, it is divisible, right?
What's that?
Since there's a 9 right there, and so it is divisible, right?
That's right. For that last one, yeah.
Mm-hmm.
So for the number 4, how do you know if it's divisible by 4? If a number is divisible by 4, it's only divisible by 4 if it can be cut in half twice.
2.
Or actually, you know what you can do is if the last two digits of the number are divisible by 4, then so is the number.
Oh, all right, I get that. Yeah. So 16.
So like a number, for example, 1,204 is divisible by 4
Mm-hmm.
because the last two digits, 4, is divisible by 4.
All right.
That's the rule.
Okay.
Or another number could be 2, 6, 7, 5, 0. 26,750.
Mm-hmm.
I'm sorry, that's not divisible by 4 because 50 isn't divisible by 4, so neither is that number. But if I said 52, or let me do an easier one, 28. 28 is divisible by 4, and so is this whole number. Okay?
Mm-hmm.
So for 5, do you know the rule for 5?
I'm guessing it has something to do with.
It has something to do with what it ends in. What do multiples of 5 always end in?
They're always multiples of 5. They're always like 5 numbers away, right? Like 5.
They are, but what do they all have to end in? Is 17 divisible by 5?
No.
Is 15?
Yeah.
Is 30?
Yes.
Is 80?
Yeah.
Is 175?
Mm-hmm.
Is 2006?
No.
Now, how do you know that? You were right on all those. How do you know? What do the ones end in? What digit do they end in? They either ended in a 0 or
All right. Or 5 and a
a
0.
5. Yeah, a 5 or a 0. Okay? It's divisible by 6 if it is even and sum of digits is divisible by 3.
Okay.
7 is the one that we don't really have a good rule for.
Mm-hmm.
So 7, I'm not even going to try to give you something. And same with 8. 8, I don't know of any good divisibility test for 8. So I'm just going to leave those. For 9 though, we have a good one. Remember, it was the same thing that I told you about 3. 3 and 9 are the same. If and only if the sum of the digits is divisible by 9.
9? Okay.
Yeah, I should have said by 3 up here. Okay, so those are all the rules. It's really good to know those because you get to a number like this, you're like, oh, 63. Oh, yeah, 6 plus 3, that's 9. So I know it's 9 times something. Oh, yeah, it's 9 times 7. Oh, it's also 3 times 3. So I could have said 3 times 21, right?
Mm-hmm.
So it's either 9 times 7 or 3 times 21. So back to the question, what multiplies to 63 and adds to 16? Look at your different options over here.
You could do 20.
These are the things that multiply to 43 or 63. Now add them together, and which one adds to 16?
7 times 9.
That's right. So you know it's going to be like this. Watch. Your first has to be, remember where your first comes from. It comes from there, right? So it has to be X and X. And what are your last going to be? Is it going to be 3 and 21 or 7 and 9?
7 and 9.
And notice what happens when you put 7 and 9 in here. What happens to the outside plus the inside? What's 9x plus 7x?
16.
Then that's why it works.
I see it. Yeah.
Do you see that?
Mhm. I remember last year when we were doing this, they gave us like multiplication charts so we could just so we wouldn't have to do what we just did. I think they just probably wanted to make it easier on us, I guess. Just look on the sheet and then see.
Yeah. Yeah, I mean that's not bad, but I mean you don't always have you always don't have that with you.
I feel like it's better to know this way. You can do it by yourself.
Yeah, exactly. So anyway, practice those, okay? Practice those. You probably have a lot of ones to practice.
I got 22 of those in my homeworks.
Perfect. Now, are all of them like this, where there's a 1 in front, where there's no number in front, so there's a 1? Or are some of them like 4, 3, or 2 in front?
Oh, look.
Because those are different. Those are harder.
Most of them are all just X's in the front.
Okay. And also sometimes you get them where there doesn't look like there's anything in the middle, but really all that means is there's a 0x in the middle. So remember that.
Go back pretty far. There's some where it says factor the expression, and it's just like x squared minus 100, and it just
yeah. So for something like that, it's the same deal though. X squared minus 100. Here, let's do that. X squared minus 100. It's the same thing, but you think of it like this: x squared plus 0x minus 100. So you ask the question, what multiplies to negative 100 and adds to 0? What multiplies to negative 100? So let's do our little chart over here, our little factor tree. How can I make negative 100? What are my options?
Can do to multiply to get it.
That's what you're doing. You're always factoring. You're always doing a factor tree, which means multiply.
Times 2.
Negative what? 50?
50 times 2.
Good. You could do or positive 50 times negative 2. What else could you do?
You can do to get negative 100. You can do.
So let me teach you another little trick. When you're doing a factor tree, let's just do a positive 100. It doesn't matter where you start. If you started at 50 and 2, that's fine. But what you want to keep doing is breaking each thing down further. Can 2 break down any further, or is that a prime number?
That's a prime number.
How about 50? What can I break 50 into?
Can do 25.
And 25 and what?
2.
And what about 25?
You can do 5 times 5.
5 and 5. Perfect. So you know what 100 equals? It equals 2 times 2 times 5 times 5. That's the prime factorization of 100. Doesn't matter where you started. You could have started at 10 and 10. If you said, hey, 100 is 10 times 10. Well, what's each 10 equal to?
2.
2 and what? 2 and 5. And what are the primes that you have down here if you put them in order? 2 times 2 times 5 times 5. You understand that?
Yeah.
So when you do something like this, it's not a bad idea to just break it all the way down and then start mixing up the factors, the prime factors, and thinking, how can I make 2 things multiply together to get negative 100, but then when I add them together, I get 0. Well, it has to be the same numbers, right?
Yeah.
So how about 10 and negative 10?
That would not work because it'd make it a positive, right?
Nope, it would work.
Oh,
if you put an X here and an X here, if you had to put a positive 10 here and a negative 10 here.
That would be negative. So if you do 2 negatives, it'll end
But
up.
these aren't both negatives, right?
Yeah.
This is a positive 10. This is a negative 10. What's a positive 10 times a negative 10?
Negative 100.
And what's the outside plus the inside here? What's positive 10? That's the inside. Plus a negative 10. What's positive 10 minus 10? Sorry, what's positive 10x minus 10x?
Positive minus 0.
It's 0.
Okay.
So that's how that one factored. See, it actually looks more complicated. This looks kind of pretty and easy and nice. This looks bigger and messier.
Yeah.
But there's a reason we do that, and you'll see soon enough. I'm not going to spoil it for you. Anyway, so keep practicing that stuff, and there's more videos on my website for factoring. You can go check out those as well. But I feel like you got a pretty good handle on this, but you really have to practice it to make sure you understand it. Okay, so practice it. Factoring is what we call, math teachers, we call it the F word of mathematics.
Yeah,
it really is. Kids just hate it because it really throws them off. But practice makes better whenever you're doing factoring.